In this lesson we're just using the table book. Let's have a look at the next lesson, which is actually a new chapter. So if you actually look at the table of contents for this book, you'll notice that in this semester there's lots of small chapters. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 smaller chapters, which means in the exam you usually have chapters grouped together. So for example, the chapter permutations, combinations, binomial distribution, and this new chapter we're doing now, they usually get put together as one question in the exam. Not always, but usually. Alright, so I'll just get the light here. Actually, do you need me to get the light? Can you see? I think that's okay. Yeah. Alright. So we'll go back to histograms for a moment. So you remember histograms? Do you? Yes. What do they look like? The thing with the thing. Yeah. I know what you mean. And here is your x, so this could be something in centimeters, like a person's height. And then what would you put on the, let's call it h actually for height. What would you put here on the y-axis? Huh? H? H for what? H for height? I don't know. Height is on the x-axis. Like this is 155 centimeters. Oh no, nobody remembers? Yeah, but if you recall, I said I don't like the histogram, or we don't usually use the histograms, the frequency on the y-axis. No, not cumulative. Oh, no. What is it? Oh, come on. No. What about if I said density? Oh, the thing. Yeah. So we usually put density on the y-axis, but in particular, for today's lesson, we'll put the relative density. So what I mean by this, so listen very, very carefully, on our histograms today, the area is going to represent the percentage. So what should the total area be? 100% or 1.00. Okay? So areas will represent how many people have that height. So let's put in an example with some numbers like this. So if I have a histogram like this, and it has this type of shape to it, and let's say this here is 160 centimeters, and this here is 170 centimeters, and if I calculate this area on the graph, then what I have is the percentage of people which are between this height. Okay? This you forgot. Would that be right? That would be right, I think. Yeah. Now, again, because you forgot, I'll remind you. No, I won't even ask. Does anyone remember how to calculate the height of the bar? So the height of the bar should be the frequency divided by the width. The frequency divided by the total frequency. I'll use small f and big F. So the small f is how many people are in this sample, in this section, and the big F is, well, no, I won't use big F. What letter did we use for the total number of people in the sample? What about if I said n? Yeah, and we divide that by the width. So in this example, let's imagine we had 30 people, and let's say there were 10 of them in this bar, what should the height of the bar be? Well, it should be 10 divided by 30 divided by, and we divide by 10 because the base is 10. So in this case it's 0.33. Yeah? 0.3. That's the height of the bar. Of course. Yes, I was right the first time. 0.333.
No.
What?
No.
Thank you, Leon. 0.0333. Thank you. So let's test that. If I draw the bar here, I know it should be straight, of course. How big is the base? 10. And how big is the height? 0.0333. And when you multiply them together, what do you get? 0.333. So are 33% of people between these two heights? Yeah, because at the start I said there are 10 people in the group of 30 that are between these heights. So you can see that this formula works. You should, if you forgot that formula, maybe you should make note of it. This is how you calculate the heights for the bars in this type of graph. Although in the exam, it's more common to not include the n. Does anyone know what would be the result if I use this formula for the height? F over W. Yeah, but what would the area represent in a... If I use this formula, what would the area represent? What would the area represent? Any ideas? Yeah? Go on, don't be shy. The whole what, yeah? Give me the letter if you know the letter. Yeah. Because how big is this base? Yeah, and or if the letter is W. So what's W times F over W? F. So the area would represent the frequency, how many people. This is the most common graph that they want you to draw in the exam. However, they don't actually say in the question which type they want. So in fact, you could draw this type as well. You just need to remember that in one case the area represents the percentage, and in the other case the area represents the frequency, but both will have the same shape, which is really what they care about in the exam. Yeah? Okay, so that was more revision of what we already did. So we'll continue with the new stuff. Does anybody remember the name of the shape of this type of graph? So if you have a histogram that looks like this, what was it, yeah? Was it you that said it? Yeah. All right. Bell curve.
You're right.
It is right, yeah. Yeah. This type is called a bell curve. Okay. Now what's nice about bell curves is in your formula book, on page 9, there's a table here, and I'll show you how to use this table. It's for bell curves. It's related to this stuff now. Okay. So there's a very special type of bell curve that has an average, mean average of 0 and a standard deviation of 1. Yeah. And we usually use this symbol to mean average. So this is the mean average and this is the standard deviation, and this is our bell curve. So this is a bell curve with a mean of 0 and a standard deviation of 1. So I'll show you what that data looks like now. Yeah? I'll just draw that again, but a little bit neater. So this is our x. Oh, I said neater. This is our density. And then this is our bell curve. Ugly stuff. Right, that's 0, that's 1, that's -1, that's -2, that's 2. And what should the total area be? Should be 100%, it should be 1. Okay? So let me show you what type of data looks like this. Loading. There we go. Let me show it again. So here are 100 numbers which have an average of 0 and a standard deviation of 1. You remember this program from Friday, don't you? So let me just put these numbers into something called data. Now it won't be exactly 0 because it's simulated, but if you look here, the average is, well, nearly 0, 0.17, and the standard deviation, it should be about 1, so 0.93, okay? So this, in other words, this is what the numbers look like. Now you might say to yourself, well, what real life situation is like this? Do you know anything that has an average of 0 and standard deviation of 1? Not really, because if you think about people's heights, what would be the average height? You know, like, what, 160 centimeters or something? And standard deviation, what would you say? Maybe like 10 centimeters? Yeah. So, for the moment, it doesn't seem like this has any real use, but we'll see how we can connect it in a minute. So, I want to show you how to use the table. So, for example, if I want to know, and actually this we usually call Z as a special, this is a special table. This is called the N01 bell curve. If I want to know how many or what percentage will be less than 1 on this bell curve. Now before I show you, roughly on my beautiful picture, what would you say that percentage is? Try a little lower. I would say about 60%, wouldn't you? Yeah, about 60%. So if we look here, the way we use this table is, this number here is our Z. So we have Z equals 1.00. That's our Z there. So down the side, you see here you have 0.1, 0.2, 0.3. Can you see that there? So we go down to 1. Now, we don't have any decimal place. It's 0. So we only go across to the first number. And what is it? Oh, I guess your 80% was much better than my 60% I thought. 0.84. So 84% of the numbers will be less than 1 by using this. We go down to 1 and we go across, and this is 0.84. Yeah, can you see? 0.8413. I see confused faces. Can you see it? Yes. Tony, you look so confused. It's okay? So what this table tells you is the area to the left on the bell curve is to the left. Do you understand?
Yes.
So if I had 100 numbers, how many of them should be less than 1? Should be 84. Let's go see. Data less than 84. Let's see, that would be data less, sorry, not less than 84, less than 1. Okay, more than 84, 92 here. But again, it's because I said it's random. Let's make it, instead of 100, let's make 1,000. So if I have 1,000 numbers from this bell curve, how many of them should be less than 1? Should be 840. So let's check. One, two, three, four. 834. So you can see that if you have a bigger n, you can see that the table book does a better job of estimating the proportions. Yeah. So what I want you to do before we do more difficult examples is tell me how many numbers in this special bell curve should be less than 2. Less than 2. So how many should that be? Have a look. 0.97, so nearly 98% should be less than 2. Okay. Yeah.
The numbers like in the...
Yeah, we'll do one going across. So for example, if I said now the probability Z is less than 1.25. So what we do is we go down to 1 and then we go across, 1.2, yes, and then we go across to the 5. And what do you get?
87.
No, the one under that. 8944. 0.8944. And how did you get that? You looked at the table book. Yeah. Is it okay? So there's a symbol we use. No? No, okay. Do I need to use the camera? No? You don't get it, then I do need to use the camera. No? Some do, some don't. I'll show you. Okay. There we go. So, there we go. Yes. So what you do for 1.25, you go down to 1.2. I can't even see that. You go down to 1.2. And then you have to go across. And up the top, you can see this would be 1.21. And this one here is 1.22. You got the idea? Yeah.
What is the Z?
The Z is the name for this special number that has an average of 0 and a standard deviation of 1. Yeah.
But in the bell curve, what represents?
Yeah, it's the horizontal. It's like the height or the data.
And the N?
The end? There was an end? Oh, that was just me revising a histogram. Right, try this for me. I want the probability that your Z will be bigger than 0.5. Try this for me. So I want the probability that your Z will be bigger than 0.5. I want this area. And remember, this table is only for the left, to the left. I think so, yeah. because this is equal to 1 minus the probability that Z is smaller than 0.5, which is 1 minus 0.6915, isn't it? So what's that? There's about 30% about. Yeah. Now, when you want to show that you use the table book to get the number, you write the following. So for example, if I want this, how do I calculate this percentage? I need to use the tables. So to show that in my work, I write this. 1 minus this symbol. Yeah, no, not table, yeah. 0.5. So this means I use the tables at 0.5.
Use 0.5 or 0.4. Also, if they go equal.
I know. It doesn't actually matter because I suppose if you want, it's really this. The same thing. Actually, which reminds me, if I just go here. Does this equal 1, true or false? 0.99999 forever. The same number or a different number to 1? You see, half the class always say the same and half always say different. Anyone feel very strongly about it? You feel strongly about it. Any reason? Guess? There's a very, very short proof for it. What does 1 over 3 equal? 0.333, etc. 1 over 3? Yeah, well, that too. And 1 over 3? If I add these together, what do I get? 1. If I add the zeros together, what do I get? 0. If I add the 3's together? 9. So in fact, they're exactly the same number. So I'm kind of answering your question there, Leon. Yes, I suppose we should use this, but that is actually the same as this. Not seen that before. No. Okay, let's move on to one that's a little bit more difficult. So I want you to try and figure out a way to get me this probability, this percentage. This is 0, of course, and this is our N01. In case you're wondering what this means normal bell curve with mean equals 0 and variance equals 1. No, variance actually. But if you recall that variance equals standard deviation squared. So in the case of 1, it is still 1. Right, I want to know what percentage of my data, that is, what is the probability my Z number will be less than minus 0.5. So I want this area. Now, before you start, you'll notice that there are no negative numbers here. It only begins at 0. So you have to think of a way to deal with that, okay? I'll give you 1 minute. Any ideas now? We'll have a look now. So, if you look up, this will be the same as 1 minus the probability that z is bigger than minus 0.5, or I suppose I really should put the equals in. So that's like what we did last time. You flip it around and you put in a 1 minus. Does that help us? No, that doesn't help us because it still doesn't give us anything in the table book, so we can't really go this way. But what you notice is that, okay, well, this area here at minus 0.5, that's the same as 0.5 to the right. So maybe that's easier to calculate. So you have probability that z is bigger than 0.5. Well, that would be 1 minus the probability that z is smaller than 0.5. And actually now this is something that you have in the table book. So that's 1 minus the table book of 0.5, which in fact is what we did previously.
Is that 0.5?
Yes. That's a 5.
That means other way is...
And this is a 5.
Yeah, sorry.
Yeah. It's symmetric. The same on both sides. I think we said this was 30%, wasn't it? Yeah. Yeah, okay. Now,
But
yeah.
how would know that the curve starts at minus 0.5 and not like at 2? From 2 to 2.
This actually goes all the way to minus infinity, and this goes all the way to infinity. So it doesn't start at 0.5, we're just jumping to that part. It technically goes all the way to infinity, but after about minus 6 it becomes so flat that it's practically 0. Okay, can we go to a little bit more of a difficult one? Okay, try this one for me. Here is my histogram, and here is 0, here is minus 1, and here is 1. So I want the probability that z will be between minus 1 and 1. So in other words, I want this area on my histogram. Okay, now I'll give you a minute to think about that. Yes. What would be the easiest way for you to get out now? Just do a quick somersault over the table. You know, just roll over. A quick flip. You can put out. You can squish forward a little bit. By the way, my graph is ugly. I know it's ugly. Of course, this height should be the same as this height here. This is only one of many things wrong with my graph. What did you get?
0.6826.
Yes, I think. Let's calculate it. So the way I'm thinking about it is that if I look up the value of 1, that will give me all the area to the left here. So I'll look up 1. But that would be too big, right? Because I don't want to include this green area. I don't want this. But this green area is the same as this red area. And this red area, 1 equals 1 minus this value. So it'll be minus 1 minus this. Yes. Now I can break it down into more steps, and there are other ways to do it. So another way you could have done it, if you look, you could have got this area here. In fact, I did get this last time, didn't I? Or did I get it for a half? What was my last one I did? Was it a half? A half, yeah. But you can get this area. You could multiply it by 2, and then 1 minus that. So you know, you have a few ways to think about it. So it would be twice the table book value of 1 minus 1. Which, what's that? About 60%, is it? 68? About. Yeah. I'll do another one like this. I know this is tricky. Yeah?
How I know the value of the area in red?
You don't. It's 1 minus the area to the left of the red.
And why 1?
The total must be 1.
Yeah.
Yeah? We'll do another example.
I use the second connection.
This one here? Yeah, I think this one's a little easier to understand. You get this one, you multiplied by 2, yeah? And then you did 1 minus this answer. Yeah. Right, try this for me. I'll draw it nicer this time. Oh yeah. Ah, so perfect. Right, minus 1, 1, minus 2, 2. So this time I want from minus 2 to 1. So I want the probability that Z will be bigger than minus 2 but smaller than 1. Yeah?
0.8641.
Seems believable. I would have thought, that seems about right. Not quite? 8.1, and you got 8.6, was it? Small difference. Let's have a look. Okay, so this one here, this will be the area to the left of 1 minus the area to the left of minus 2. Yes? Yeah. Now this is good. Why is this one good? Well, this is in the table book. Yeah, that's okay. Hey, look up, guys. Albert, you can look up. Let's start again. You watching, Albert? So this is the area to the left of 1. So that's everything to the left minus everything to the left of minus 2. So that's this one here. This is good because it's in the book. This one's bad because it's not in the book. But there's a little trick, maybe you figured out the trick, that if you have here 0, minus Z and Z, and you want the area to the left of minus Z, that's equal this area here, which is 1 minus this area here, which is 1 minus that. So this is how you could get rid of a minus. You can do 1 minus. So if I do that trick again here, that would be this minus 1 minus this here. And that's great now because that's in the table book. So it's table book 1 plus table book 2 minus 1. Okay, so what did you say this one was? The first one, 1. 0.8413 plus 0.9772 minus 1. So what will that be? 8185. So that's 82%. Okay. Now I want you to try these for a few minutes for sure. You can skip for now, you can skip 1 to 4 because I want you to practice using the table book. So that starts at question number 5. So can you look at 5 to 19 now? 5 to 19 for now. Can I close this? And we'll do